Okay, this is a brief screencast to basically illustrate to you some ways in which you can kind of think about what the data set means in terms of the results that you find in biological terms. So a student was in my office earlier today, and I was trying to think of ways of getting that student to think about what the actual outcomes mean and how to frame those outcomes when you're writing the explanation at the end of your report for the researcher. And so I thought about it in terms of kind of different models of thermoregulation that we can think about. So in these slides, the different types of temperature are going to be represented by different colored normal curves. So the black normal curve is environmental temperature, the blue curve is wall temperature, the red curve is body temperature, and the green curve is preferred temperature. So in the nullest of all models, you don't have a physiological set point, which means that you don't really have a preferred temperature. You don't have any sort of internal mechanism for saying, I, gecko one, want to be at a particular temperature. And not only that, because you don't have a set point, you also don't have any ability to thermoregulate. You haven't evolved any behaviors that help you raise your temperature. So in the nullest of all models, you live in an environment that is a particular temperature. In this case, it's an average temperature. And you don't have a set point, so your set point doesn't really exist, so it just takes on the temperature of the environment. So you don't seek out any particular place on the wall, and so your body temperature ends up matching the wall temperature, which ends up matching the environmental temperature, which ends up matching the preferred temperature. And in this case, you wouldn't expect there to be any effect of temperature type being significant in your ANOVA. Now, populations might be different because Galveston is warmer than Edmond. Seasons might be different, but you wouldn't expect temperature types to be different from one another because there's nothing in the thermal biology of the lizard that makes them seek out a different temperature than just the environmental temperature. So you might have a population effect, you might have a seasonal effect, and you might have an interaction between those, but you wouldn't see any effects of the, the temperature types. Now imagine a somewhat less null model. Let's say that you do have a preferred temperature, but you haven't evolved any behavioral mechanisms to thermoregulate yourself because you're normally an exotherm. But for whatever reason, in your particular lineage, you haven't evolved the behavioral strategies to behaviorally thermoregulate. So if you find yourself in a slightly cooler environment than your preferred temperature, you don't seek out warmer environments on the walls. And as a result, your body temperature takes on the temperature of the wall, which is also the temperature of the environment. In this case, you would expect to see an effect of temperature in that you would expect to see preferred temperatures being different from all of the other temperatures, and you would also expect to see seasonal and population differences, but you wouldn't see a lot of differences among temperatures. Now, if we look at the full model, we have a preferred temperature. So there is a temperature at which you like achieve your physiological best performance. But you find yourself in that same somewhat cooler environment. But in this case, you do have the ability, you've evolved the ability to behaviorally thermoregulate, but your thermoregulation is constrained by the fact that you're in this somewhat cooler environment. And so you may seek out warmer areas in your environment such that you seek out positions on the wall that are warmer. As a result of that, your body temperature is warmer than the environmental temperatures in general, but the environment is constraining you such that you can't reach your actual peak, your average preferred temperature. And so now you would see that environmental temperatures would be different from both wall and body temperatures, and those would be different from preferred temperatures. At the same time, that population and season will also be affecting this. Well, how does population and season affect this? Well, now imagine that you're in wintertime in Edmond, Oklahoma. Your preferred temperature is still way up here. But your environmental temperature is now really cold because it's January in Edmond, Oklahoma. Because you have the ability to thermoregulate, you might seek out in Edmond, Oklahoma, the warmest places on the wall, which does raise your body temperature slightly above the environmental temperature, but you're way far away still from the preferred temperature. And so now, in this case, you start to see the temperature type effect in your ANOVA model becoming really, really significant, partly because you're just constrained by the environment. In a similar way, if you're a gecko in the winter in Galveston is substantially warmer. So you have your normal preferred temperature. That's not changing from slide to slide. But your environmental temperature is also warmer because you're living it up in nice sunny Galveston. As a result of the fact that you have the behavioral capacity to thermoregulate, you might choose warmer areas of your environment, which once again raises your body temperature above the environmental temperatures, but once again does not quite allow you to achieve your preferred temperature. So once again, there would be differences among different types of temperatures, but you would expect preferred temperatures to still be different than the actual body temperatures that get achieved. Now imagine either of these populations in the summer. In the summer, your temperature set point, your preferred temperature is still the same, but now the environment that you are in is warmer. But in this case, the environment substantially overlaps the preferred temperature range, such that if you are capable of doing behavioral thermoregulation, you might seek out cooler parts of the wall, which then brings your body temperature down closer to the preferred temperature. And in this case, you might or might not see differences between body temperature and preferred temperature, but if you do see those differences are not going to be as pronounced. So as you look at all of the differences that you find when you do the Tukey-Kramer test, think about these in terms of how are geckos that live on walls in these two environments who were sampled at different times of the year, how would you expect these data to turn out under different levels of the fullness of the model? No abilities to thermoregulate, and no physiological set point, a physiological set point without the ability to thermoregulate, a physiological set point with the ability to thermoregulate, but that is constrained in various ways by the environment that you find yourself in. And I think if you approach it that way, you might find it easier to think about the results that you're seeing. Let me know either way if this helps you or this doesn't help you, and I can attempt to be more clear. So that was all I wanted to share.